everybody. We're in our last unit now. As soon as we finish this, we're done with everything. So this is the statistics unit, which is kind of fun. We're going to start off with a pretty simple lesson, which is just looking at how we can graphically represent data. So some of these things we've seen already in 6th grade, even in 5th grade, and again in 7th. So let's start off talking about types of data. So quantitative data is data that's on a single variable, and it's often collected in order to understand how a characteristic of a group differs amongst the group members or between groups. So for example, if we ask a question like, how old is a typical fast food worker? It's helpful to take a survey and then see graphically how the ages differ among the group. So for exercise 1, we're looking at Charlie's Food Factory, which currently employs 28 workers, and these are their ages. Now this is a dot plot, which you first learn in 6th grade, I think. You probably did it even earlier than that, but in middle school you first learned it in 6th grade. So a dot plot, as you know, it shows the frequency of ages. So this is age 15, there's nobody at age 15. We start off at 16, there's 2 workers there. You can see the highest number, most people that work there are around 20 years old. And then you can see older workers are much fewer, right? So I've got someone here who's 42 years old and someone here who's 38. And so most of the people are young, right? So how many of the workers are 18 years old? So you find 18, which would be here, and you just count 1, 2, 3, 4. So there's 4 18-year-old workers. What's the range of the ages of the workers? So remember back in the day, you do the highest minus the lowest value to get the range. Okay, so the oldest worker is 42, and the youngest is 16. So you just do 42 minus 16, and you get 26. So the ages of these people who work here range 26 years. Would you consider this distribution symmetric? So this definitely does not look symmetrical because all of the data is clumped down here. Okay, if it's symmetrical, you usually get like a nice centered look in your data. Okay, so no, this is definitely not symmetric. The data, it's concentrated on this end. Another way of saying that is clustered at one end. And it's stretched out to the right, kind of. And the statistical word we would use there is skewed. You don't really need to know that yet. Off to the right, okay? The mean or average age for a worker is 22 years old. Why is this average not representative of a typical worker? So let's take a look. The mean the mean is 22. Here it is. So why is that not a good average? Well, look at most of the workers are younger than 22. So if you remember back in 7th grade, hold on, let me finish writing this. Okay, so it really doesn't make sense for that to be a mean, right? If you remember back in 7th grade, we talked about outliers and how they can affect the mean. So you're calculating your mean. You have these higher outliers. There's not a lot of people who are older than 30 here, but because 30 is a larger number, when you calculate the mean, it makes the mean larger, even though it shouldn't be. So sometimes that happens. Okay, so exercise 2, a farm is studying the weight of baby chicks, after 1 week of growth. They find the weight in ounces of 20 chicks. The weights are shown below. Let's construct a dot plot. Okay, so going through here, there's no need to put it in order from least to greatest because you can just cross them off as you go. So 2, you just put a dot over 2. 1, make sure you cross them off as you go though, otherwise you could lose count. 3, 4. Now when you get to a repeated number, you just place the dot on top. Okay, and that's how we get our visual of the frequency of of values in your data set. Okay. Just really try to get everything even. You know, you don't want to make your dots different sizes so that you can't really tell. 8 over here, 5, 4, 6, and 3. And there's our dot plot. And this would be a great example of a symmetrical data set, right? It's pretty symmetrical. There is one little outlier over here, but it's pretty symmetrical. All right, let's move on. Now we also learned about histograms back in, I think, 6th grade. Exercise 3, this histogram shows the ages of the workers at Charlie's Food Factory. Same exercise, it's just in a different format. So remember, the difference between a dot plot and histograms is that histograms put things in intervals. Okay, so it's a range of ages instead of the actual number of ages. So in this case, how many workers have ages between 19 and 21? So you go to the 19-21 range and you go up here and you can see that it's 11. Now, what is the disadvantage of a histogram compared to a dot plot? We can see the ranges, but we can't see the individual data values, right? We can't see how many of each number there are. So maybe it's 19 to 21, but maybe they're all 21 years old, right? So you can't see the individual data values. We can just see the grouping that it's in. So, does the histogram have any advantages over the dot plot? It's easier to see the totals for the amount of data points that fall into certain ranges, so we don't have to count the dots, so to speak. So it's easy to see ranges, don't have to count the dots. Okay. And finally, to finish up exercise 4, we're going to make our own histogram. Okay, so what we have here is the 2006-2007 Arlington High School varsity boys basketball team. They had an excellent season, compiling a record of 15-5, which is 15 wins, 5 losses. Total points scored by the team for each of these games are listed below in the order in which they were played. And so in order to make a histogram, if you recall from 6th grade, which I don't know if you recall or not because I wasn't teaching you in 6th grade, you have to tally up the numbers in the range, and then you write the frequency, and then you make your histogram there. So first I'm going to just put a tally mark in each section where it belongs. So 76 goes in between 70 and 79. 55 goes in 50 and 59. 76 goes between 70 and 79. 64 goes in 60 and 69. 46 goes here. 91 goes here. 65 goes here. 46 goes here. 45 goes here. 53 goes here. 56 goes here. 53 goes here also. 57 goes here, and remember, once you get to 5, you cross like that, right? 67 goes here. 58 goes in here. 64 goes here. 67, 52, 58, and 62. Okay, so now you write the frequency, meaning just the number. So I've got 3, this is 8, 6, 2, 0, and 1. Okay, so you can now create your histogram. You just have to group things by their intervals. So we have 1, 2, 3, 4, 5, 6 groups. So all you have to do is kind of decide how many boxes you want to make each one. So you could, let's see if 3 will fit. 1, 2, 3, 4, 5. No, it's not enough, so we have to do 2 boxes. Okay. You need 6 intervals. Okay. So 1, 2, 3, 4, 5, 6. So my first interval is 40 to 49. Okay, second is 50 to 59, 60 to 69, 70 to 79, 80 to 89, and then 90 to 99. Okay, and then we're going to look at our frequencies and we're going to adjust accordingly. So I think going up by 1 is fine here because we don't go up very high. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Who's burping? The minions? He's playing a minion game. Okay, so between 40 and 49, we have 3. So what you do is you take up those 2 boxes like this, and you shade it in like so. Next is 8. So 50 to 59 went up to 8. Oh dear. I really need 2 hands for this. And shade it in. Doesn't have to be perfect, but 60 to 69 is 6. Okay, so that's here. 70 to 79 was only 2. There was nothing for 80 to 89, so you just leave it blank, and then just 1 for 90 to 99. Oh, wait. Hold on. I can't see. 80 to 89 is here. Sorry about that. I mean 90 to 99. Okay. And that's your histogram. Only thing I forgot to do is label it. So this would be number of points, so I'll put it down here because I don't have any room up top, and typically they are kind of labeled at the bottom anyway. Okay, so this was the number of points, and this was the number of games. And there you are. Have fun with your data, guys.